Hello, this is Brian. Welcome back to my shop. Today we're going to work on a rather low quality Harbor Freight 4-inch belt sander. We're going to spend $13 and we're going to transform it from something that's relatively useless to something that's going to be useful. Now bear in mind, it still won't be a high quality tool. It'll never be that, but at least it'll be useful. Stand by and let's see what we're going to do. Here's the tool in question. It's a central machinery, which means Harbor Freight 4-inch belt sander. This belongs to my son. It came out of his garage. Forget the disc sander. I took that off and recycled all those parts. It was so bad, there's no fixing that. But all we're interested in is the belt sander. The problem with this machine is the motor. The motor is such poor quality, it's probably too small for one thing. It's not a very efficient motor, and it barely has enough power to start this thing. When it's cold, it won't start it. Then you can drag the belt down real easy. And that's because this is a PSC motor, which is called permanently split capacitor. And we can fix that by adding one of these solid state relays. In fact, here's the information from the relay that I used. I do want to point one thing out. I thought this was a Supco brand relay. That's what I used on my other project, which I've done before. I'm going to show that to you in just a second. But this is a Chinese knockoff. There's the brand Vialu. And I don't think it works as good as the other one, but it's only $14. So let me show you what I've done in the past. I've done this before, and it's been very successful. If you watch my videos, here's a project I worked on, 7 or 8 years ago. It's a Delta 6-inch bench grinder, and it started so slow, it just wasn't usable. And I put one of these relays on, these solid state relays. Now this is a Supco, and this thing starts like a dream. It went from unusable to one of my favorite tools. I mean, it starts like it's a three-phase. It's absolutely wonderful. I'll put the link to the video down in the description. Okay, let me explain to you now the difficulties of adding one of these relays. Adding this relay is definitely not plug and play. You're going to have some motor experience, some knowledge of electricity to be able to do this. The first thing is selecting this relay. These relays are sold by horsepower, and all you really know from this thing is it draws 3.5 amps. See it there? 3.5 amps. On the label, it tells you that this is good for 1/12 to 1/5 horsepower. And this motor is probably a 6 horsepower or something on this 4-inch. But notice the 6 amp rated load amp. RLA is used in refrigeration. This thing is made for refrigeration compressors, by the way. But anyways, it's the smallest they make, and this is a small motor, so choose that one. Now next week I'm going to work on my, I have a Grizzly drill press, and that has a larger motor. So I think I'm going to use the medium-sized one, but that'll be another video. So selecting one of these is somewhat difficult. You have to make sure you get the right size. 2, and this isn't a problem, but I'll just talk about it while my finger's right here. They don't send you a bracket. There's no way to mount this thing. I made that clamp myself out of a piece of metal from a tin can. But the problem is wiring these. You have to know how to work on a motor. You have to isolate the start, run, and common out of this motor, because refrigeration compressors are that way. There's terminals for start, run, and common. And this motor has these three wires, white, red, and black, that go to start, run, and common. These 2 wires off to the side are the line, the 110 volt. So that's no problem. You snip the wires going into the motor. I had to open up the motor. You can see evidence of how I did that. I marked the end belt, took the motor off. Then I had to bring out the common, the start, and the run windings. And that's somewhat difficult to do. I cut a hole in the capacitor cover and brought him out. And I elected to leave the run capacitor in. Everything is difficult. They make these things difficult, like these wires. If the manufacturer would have left 1 more centimeter of wire, would have been nice. It was so tight getting in there. So I soldered these things up, because there wouldn't have been room for a wire nut. So it's difficult to get in there and work. Here's the process I used. And again, this won't be for everyone. First, I made a diagram in my own way of making diagrams, and I've made a lot in my life, trust me, of how the motor was wired. In other words, inside the motor, I had to know what color wire went where, like blue to motor winding and things like that. I made note of that. Then, even before I bought this relay, I went and got a diagram of how it's supposed to be wired. Here's the refrigeration compressor. You have these 3 terminals, common, start, run. And these things fit on refrigeration compressors, almost no-brainer. But to get them to this motor, what you have to do is take this diagram, combine the two, and then I made a diagram of how I wanted to wire this thing. And that's exactly what I did. So, we should start it up. I'll put my amp probe back on, and we'll start this thing back up. This motor wants to draw 3.5 amps when fully loaded. So I'll put my amp probe on the 6 amp scale. So this will run just slightly under 3 amps. So the needle will be just slightly off center. It'll be a little bit noisy. This may be your chance to turn your speaker volume down. Okay, are you ready? Let's turn this on. You can see the needle swing on my amp meter. That's the surge of current that this relay is putting into the start windings. Let's do it one more time. Watch how the needle deflects almost all the way to the left. That's the relay giving this thing a real surge of current in the start winding. This is then known as a capacitor start motor, and they start with high torque, unlike the low torque from just a permanently split capacitor or a PSC motor. So here you go, plug your ears, let's turn it on one more time. And I've been sanding with it, but I have my dust collector hooked up to it then, and that makes a lot of noise. And I can't drag the belt down. I shove a block of wood, I have a 2x4 I shove in there as hard as I can, and it keeps on going. So I think this tool is going to be useful now for my son. He can put it out in his garage and use it. I think with this relay, which was only $13 or $14 on eBay, really makes a difference. Like I say, I've done it once. It was very successful. I did it to this one, and look what I'm going to do next. This is my standby Grizzly drill press out in the garage. It's an okay drill press, but there too, it's underpowered. So I'm going to open up this motor. I'm going to bring the leads out to start running common leads, just like I did the belt sander, or like I did this thing. And I'm going to put a start capacitor on the drill press as well. So it is possible to make cheap tools like this better. But yes, I realize it's difficult to do unless you have knowledge of electrical motors and some wiring skills. But it can be done. It's pretty cheap to do. Don't be afraid to try it. because it makes the tools so much more useful. Well, once again, this is Brian, and I thank you for watching this video. Good luck to you. Bye now.